All right, welcome to part 3. I almost said 4. Part 3 of this K7500 chassis repair series of 4. So let's get this one inspected and see what we can find. It's complete. It did not have the remote board. I got 4 of these. 2 of them had remote boards, 2 of them didn't. So I'm using the remote board from the first 2. So we're not worried about it being broken or cracked pots because we know it's good from the last 2. The neck board on this one actually is in much better shape than the previous 2. We'll go ahead and get it disconnected off of the chassis here. And it actually is in much better shape. It has not been butchered. Relatively low life apparently because it's not quite all burned up. It is burned a bit, but not as bad as the previous ones. It'll of course need fresh solder, and there is one lifted pad here. I don't know if you can, let me zoom in here. So as normal, there is still lifted pads right there. But that appears to be, well, this one's lifted as well slightly. So it'll take some rework, but nothing too bad. Hopefully we don't have neckboard problems on this one. There's a missing adjustment here for the red drive, which isn't a big deal. These are all still factory glued in place, it looks like, from whatever tube it came from. So hopefully we don't have any neckboard problems on number 3 here. I don't think we will based off how it looks. But I'll still do all the necessary reflow and repairs and stuff that's needed. The main chassis here, again, it's in fairly good condition like the first 2. Original caps except for a couple. It's obviously this one's been replaced because of the glue, but that one hasn't, and this is still the bipolar cap, and you know, a lot of these, that one hasn't been changed. And so yeah, original caps except for maybe 1 or 2. And I've got my width transistor and pre-installed, if you will, or installed. And just looking over it here, like the first 2, seems to be intact. Nothing is jumping out. The linearity coil is kind of messed up, but it's glued in place, so I'm not going to mess with it. Yeah, well, again, it looks okay. Solder side. Looks like someone has been doing some work. Obviously, someone has been doing something with this resistor because they've got a jumper here, kind of like the last one. So I don't know if this works or not. You know, when I see stuff like this, obviously someone's been doing some kind of troubleshooting. But it looks fairly good. Someone's reflowed some of the neckboard pins here. They've reflowed the header pins, so someone's done some previous reflowing work. It's quite obvious, especially with all of the, you can see this kind of stuff here where someone's done something. There's flux spread on there, and there's flux around the pin, like someone's added fresh solder. So it's definitely had some work done to it. So I can't say, obviously I have not powered it up, so we'll just do our testing here, see what we find. Hopefully this has some type of issue because we're 0 for 2 on really anything kind of educational on these. Alright, first things first, let's do our, what do we start with? Let's start with our voltage regulator. .5 and 1.0, that's good. Our switch mode power supply. Oh, I got them backwards, sorry. Negative has to go inboard. That's good. Let's go back here again. Good and good. 1.7, 1.8, 1.0. Yep. So that's good. Q703. 0.6 and 0.6, that's good. I guess while we're down here we can check the HOT. It should be over here. Oh, it's got kind of crappy solder joint on there. Right here. You can see these 2 are fairly decent. This one's kind of not much to it. I mean, it's not cracked, it's there, but that one's decent, that one's decent. This one's kind of anemic. But we'll go ahead and just test it, I guess. Let's zoom back out. Okay, negative, and do we touch here? Oh, uh-oh. Hey, finally found something. HOT is dead shorted. Interesting. Okay. Well, usually when that happens, we got the polycaps here. You've got these three polycaps, C724, 723, and 718. The smaller one here, 718, usually that reads shorted when you get a shorted HOT. So I'll bet that reads shorted as well. It does. The other one is good, and this one is good. So that's interesting. Shorted. Shorted. So now, I wonder, let's see, is that everything? I think, oh, sorry, I got a metal table here. That was everything, right? The polycaps, Q703, voltage regulator, switch mode power supply chip, HOT. We can test our diode one over here. Again, negative, positive. D707. That tests good. Okay, so we know that's okay. Interesting. Okay, well, with all of that known, I will say, just based off previous experience, that C121, I mentioned before in the first video, part 1 of this series, that C121, when C121 is shorted, that can cause the HOT to short. So since we have these two components reading shorted, C718, the polycap right here, I think it was 718, right? Yeah, C718 reads shorted, HOT reads shorted. I'll bet you dollars to donuts C121 also reads shorted. So if we come here to C121, and we can just go ahead and go to our continuity mode. We touch our other leg. Any bets? Shorted. 1 ohm. So now we have to figure out if it's the HOT that is shorted, C121 is shorted, or C718 is shorted. So it's going to be one of the three. So the first thing to do is we'll turn on our desoldering gun, and we'll just lift one leg of C121 and see if it still reads shorted. If it does, then this is the cause of our HOT shorting, and 718 is probably just fine. So it's going to come down to eliminating one of the three, if not all three, of the components as the cause of the short. And then after we fix this problem, then we'll test it again. If it tests good, then we'll, with everything else testing okay, the neck board being okay, we'll just put it on the tube and fire it up and see what we get. So in the meantime, let's turn my iron was off too. So I guess we'll have to wait here a few moments. There's not really much else to test while I'm waiting. I'm just looking over from the side here. I guess we can test R811. I didn't mention this in the part 2, but we'll go to ohms here. And R811 is this guy here, right there. If that is open or way out of tolerance, you'll have either a black and white picture or no color at all. Which, well, no color at all is black and white. I'm sorry, I'm an idiot. So we want to test it. It's supposed to read between 50 k ohm and 100 k ohm, depending on the revision of your chassis. You know, if it reads 75 k ohm or 90 or 52, that's all. It has to be between 50 and 100 k ohm. So if we test R811 here, it reads 35k. That's low. Just for comparison, here's parts K7500 that I have. If we read R811 on it, see, that's 76k. That's perfect. So that's quite odd. I've never seen one be that low, so that's kind of out of tolerance, but I'm not concerned about it because it's not way out of tolerance. It is low, but there may be something else happening that's causing it to be low. I mean, we can take it out of circuit and test it, but 35 is, you know, 15k below the 50k threshold. So let's just go ahead and leave it for now, and if we get this running and working, we'll see what kind of colors we have. If we have vibrant colors, I'm not going to worry too much about it. But that's something else to be cognizant of when you're looking at these chassis. Okay, so we've got our iron hooked up. Let's take one leg out of C121. I'm going to end up having to take the whole thing out. Okay, C121 is out. Let's test it. Is it still shorted out of circuit? It is not. It is not shorted. So C121 is good. This can be a cause of HOTs. If you're putting HOTs in here and it blows and it blows and it blows, you always want to check C121 because that's a very highly known, well-known culprit of causing that. But we can also test the pads. The pads that C121 was in and see if they're still shorted, which they probably are because the HOT is shorted. We'll test them anyway. That was this pad and this pad. Yep, 2.5 ohms. So we can go ahead and put C121 back in. Let me take some of this away here. Let it heat up. There we go. Now this pad. It's a ground, they're both a big ground plane, so it takes a while to heat them up. No sir, I don't like it. That's got a bunch of solder on it. Let's grab. Oh. Looks like it worked itself out in trying to put that in there. Okay. All right. Okay, C121's back in. Let's just go ahead and remove our HOT, because I'm sure that's the actual culprit. Alright. Right out. So now let's test it out of circuit. Base. Shorted. In the garbage. It goes. Now, let's test our pads to make sure that nothing else on the chassis is shorted. Pads are good. Okay. So if you did this and you still had a short, then you know something else is causing it to read shorted and or prying the HOT. So if you pull the HOT, if the HOT reads shorted in a circuit, pull it out, test it out of circuit. If out of circuit it reads good, test your pads. If your pads still read shorted, then there's something else, and then you can trace it back from that point. That's usually how you find, that's how I found, the first time I ever discovered that C121 was shorted, was doing that. I pulled the HOT, the pad still read shorted, tracing the circuitry, I found C121 shorted. So if you have a shorting HOT on a 7500, you want to check C121. If you have a HOT shorting on the 7400 and the U2000, I believe it's the same capacitor you want to check. But on a U5000, there are, I mentioned before, there's two resistors here that aren't on the other ones. There's R760 that goes here to here, and R765 which goes here to here. Obviously you see they're not populated on this one, but on the U5000, these can open up. If these open up, that'll take the HOT out as well, so just putting that out there for you. Now that we know that nothing else on the chassis is shorted, if we go back to C718 and we touch those pads again, no longer shorted. I'm upside down, there it is. So our polycaps are good. So I'll bet you we simply had a faulty HOT, and that happens. Sometimes you can have an HOT just die from, you know, use over the years and nothing else caused it. That's quite possible. It may just be the HOT died. So with nothing else causing the HOT that we can see on this, at this juncture, there still could be something else causing that. So the first thing we'll do is put an HOT in here and turn it on and see what happens. If it blows immediately again, we'll look a bit deeper. So I've actually got, where's my stockpile? It's K7000 stuff here. We've got 3 of the 2SC3688, and we have, where are they at? Do I not have, I don't think I have any more. There's an alternate. Forgot I had that. That's an extra, is it 790? 804. I have an extra remote board that'll work for a 5000. And yeah, I don't think I have any of the alternate HOTs. I don't appear to. So we'll have to stick with what we've got. Okay. Alright, let's grab one of these. Make sure it reads okay. Before we do that, we'll bend this out like it should be. There we go. Okay. And good. And I believe the other leg should be open. Yep. And this should have continuity. Yep. Okay. I guess we also forgot to check our R104, but I'll bet you it's 10K. Oh, wait a minute. Wait just one doggone minute here. Very interesting. Glad I tested that. It's supposed to be... Well, that was weird. I just got an error on my camera that said recording has stopped due to insufficient write speed to the card. Never seen that happen before, but anyway, it seems to be okay now. Look at that. So this resistor is open. That's okay. I don't know if that reading is supposed to be good offhand or not, but our 10K ohm resistor is open. You've seen me check this in the other ones, and sure enough, this time we got an issue. Very interesting. So something in the power circuit could have taken out the HOT. So let's do some more troubleshooting here before we replace the HOT. I'll put it aside. We already checked our voltage regulator, and that was good. We'll check it again here. 5 and 1.0, yep, so that's okay. Huh. C106, is that good? Just make sure it's not shorted. That's open. So with this resistor being open, that means nothing else is shorted here in this section. If something else in this section was shorted, you would see 0.0 here. What's odd though is that when it was up here and I checked it real quick, it was 0.0. I don't know if it shorted on the camera, but that's what made me go, oh, look at that. But now for some reason it's reading open. Either way, so let's just go ahead and snag this out real quick. That's why I always go to R104 here, because that'll tell you a lot. Since it reads open, I know nothing else in this section is shorted. It may just be a simply open resistor, which has been known to happen. And I have to snag one from somewhere. Out. So let's test it out of circuit here. Touch our leads together. 0.1. Touch this. Open. Nothing. Huh. Quite interesting. Well, that definitely would have caused a lot of problems, most notably the HOT going out. So that may be the cause of our problem here. So can I snag one here from somewhere? I can. I've got my damaged in shipping I got my damaged in shipping U5000 sitting here. You can see it did not have a good day. So let's test this one. 10K. Alright, ladies and germs, let's snag this out of here. Out. And we'll test it again out of circuit. 9.72. Let's put it in here. Alright, nice shiny solder, looking good. What do we get now? $9.64K. So, yep, I'm confident that that will do the trick. We can test the diode here just to make sure. Diode's good, 0.321. Does anything look hot or melted or burned? Not particularly. Everything looks okay. These diodes in the power circuit are kind of suspicious right here, but I don't see anything cracked. We'll worry about the reflow later, because nothing else looks bad. You can tell some work has been done in here. So I'm confident that's probably going to be the only issue. Glad I found it, or this would have just gone out right out immediately. It looks like our insulator is okay. I don't see anything really wrong with it. So let's get this in here. Get our screw back in. Get this tightened down. Now you don't want to over tighten this, just snug is good. There you go, that's all you need. So I'm going to take this, throw it in the trash. It's not uncommon to see that resistor go bad. I've actually had 2 or 3 of them. That's why if you look here on this 7400 parts chassis I have, you notice it's missing. So it's not uncommon for those to be bad. Okay, so let's solder in our HOT. Okay, cut these taller legs off. Test it, make sure it's good. All right. Well, let's hook it up, cross our fingers, see what happens. Actually, before we get it hooked up, I want to show that I've got the neck board all repaired. I got the resistors evenly spaced out, I got the heat sinks flattened, everything is equidistant and secure and nice and looking good. On the back side, I removed all the original solder, put new solder on, cleaned up the pads. Again, it's not a beauty contest, but it should be much better now. So, yep. Everything is nice and secure. Yep. So, yep. Hopefully, we don't have any issues with the colors. Hopefully, it turns on. With what we found, I'm hoping it just turns on, basically. But I did forget to do this. And center. Yeah, that's never been moved. Center. It's important to do this because these have been sitting in one position for so long that they develop not corrosion but high resistance in that setting, and it'll give you odd issues sometimes. Okay. Now we are ready. Okay. Let's get you out of the way. Got our G2 and our focus pin. Okay. And our remote board. All right, I believe that's it. We got everything should be ready to go. We got our R104 changed out, HOT changed out, everything else tested good. Remote board, neck board hooked up properly and it's repaired. We got our width transistor in, so Ain't nothing to it but to do it. Let's get it on the tube and cross our fingers and fire it up. Okay, moment of truth. All hooked up. And I've counted to 6 and it's good to go. We got our TPG turned on. Cross our fingers. 1, 2, 3. Nope. You can hear it ticking. Shorted immediately. Listen. So, unfortunately, something's ticking out the HOT. Further troubleshooting is required. Stand by. So the first thing we're going to do regarding the testing is we have to remove our blown HOT so it doesn't affect our other readings. I went ahead and, off camera, I went ahead and just took it out. But the first thing we'll do, I guess that's the first thing. Second thing is we're going to do our light bulb test. The light bulb test will test our power supply section to let us know if we have a power supply section problem or if we have a horizontal section problem. So the way this works is on the K7500 and the 7400 there is L100. You can see here L100. You desolder this side of the coil, lift it up out of the board, and connect 2 alligator clips to it. You can see I have a red and a white one, and if I lift it you can see the coil move, so it's removed from the chassis. The red lead is going to go to your positive to test your B+ voltage. The white lead will touch the end of your light bulb, and you touch your light bulb to your heatsink, it should light up. So what will happen is when we do this test, obviously your ground is going to go to, I have it clipped to the DAG, which is right here. So we have our ground hooked up, we have our positive hooked up to our L100 for our B+ reading. We have the other lead going to here. You want to make sure it doesn't touch anything because you'll zap it. You touch the lead to here and touch this to here, it should light up. If it lights up, our power supply section is good, and we have to worry about something on this side that's bad. If it does not light up, then we have a problem with our power supply section. So here's how this works. Let me get this on the overhead camera and we'll see what we get. Alright, so first things first here, let's turn on the chassis. With the L100 removed from the chassis, it won't do anything, plus there's no HOT, so you don't got to worry about it. On the U5000, you may hear some hissing or something from the power transformer. You may hear some noise, like generally this will start to hiss and things like that, so don't worry about that. But we'll turn it on here. Okay, it's powered up. So we'll take our light bulb, we'll touch it to the frame, we'll take this, it's coming off the coil, and we'll touch the light bulb. It lights up. Now let's see what our B+ is sitting at. It's AC and DC. Okay. So 165 volts. That's way. It should be about 120. You'll notice here that when I touch this and then go to here, it goes down to 135. That's actually normal because this is a load. It's putting a load onto here, so that's why it jumps from 164 to 134. But the B+ pot's currently turned as far down as it can go. And this is actually a good reading. 135 is actually a good reading because once you get this system hooked up and it's operational, it should be around 120, 121, 122. So that's a good reading. 135 is actually a good reading. And as you can see, the light bulb lights up, and we have 135.5. So we know our power supply section is good. So now we got to figure out what's going on in the horizontal circuit that could be causing this problem. We already know C121, it doesn't read shorted, but it still may not be good. So I'm going to replace C121 and C119. That C121 and C119 are the 2 metal film capacitors right there by the L100 coil. Let me set this down. I don't want to touch the frame or it'll zap it. You can see it. Actually, I still have power. Let me turn power off, and you'll see that it starts to bleed away. But C121 is right here. It's that metal film capacitor we already tested. And C119 is this guy here. It's a smaller metal film capacitor. So I'm going to replace those from a donor, and that'll be the first thing I want to do. See, I had a U5000 that I recently repaired that was blowing HOTs. And I did a cap kit, I did flyback, I reflowed, I did everything humanly possible to try and figure out what was causing HOT to blow. And it turns out nothing was causing the HOT to blow. The HOT was just crap. It was one of these, and I put in one of the alternates, the F type. Let me actually go get it. I'll show you. I don't have any left, so I tried one of these, but I put an F type HOT in, and it fired up and was perfect. So there was nothing wrong with the chassis. There was just these were not any good. So I'm wondering if maybe that might be the case. Unfortunately, I don't have any other of those other F types. I'll grab the 5000 and show you what it looks like real quick, just so you can see. But it doesn't mean that there's something wrong. Not something wrong. It doesn't mean there's not something wrong with this one. Easy for me to say. But that's how you do the light bulb test. Let me turn this back on. You'll see this jump back up. So yep, it's fairly simple. We touch this to the frame and it lights right up. So we know we have a good power supply section. And I'll take you back off the overhead here. And you can see that it's how it's hooked up there. We are disconnected, so I'm going to go, or turned off. I'm going to take this lead off of here, and I'll take this lead off of here. And you can see that I have, it's lifted up out of the, so that's how you do it. Then of course you'll put that back in and go about your business. And then, so C121 was this guy, and C119 is this guy. So I'm going to change both of those out, put that back in. I've got two left here. Two left to try. If I put another one in and it blows, I'll have to come back and do some more research. But I'm going to, off camera, I'm going to poke around and see if I can find something. If I find something, I'll come back. If not, I'll put another HOT in and we'll see what we got. But we know our power supply section is good. So it's going to take a little bit more troubleshooting. So I'll replace C119 and C121 and do some more testing of all the resistors, which I've kind of already done. But I'll do some comparing and contrasting of all the main high wattage resistors that are in the power supply section, even though I know they're good, and then the ones like this one here and these over here. And I'll do all of the normal testing that you should do. And if I find anything out of whack, I'll let you know. If not, after changing these two out, we'll throw another HOT in and see what we get. So stand by. All right, real quick though, I want to show this alternate HOT. This is a U5000 that I recently repaired. And you can see it's a totally different type of HOT. It's much more robust, and in my experience they're a bit more reliable. So that's what those look like. So now let's get this further troubleshot and I'll see what I find. Well, I spent hour after hour after hour painstakingly combing through every component, and I could find nothing out of tolerance, nothing open, and nothing shorted. Everything checked good. I could not find the reason as to why the HOTs were blowing. So I ordered a full cap kit and installed a full cap kit. Put a new HOT in, blew. And I ordered a bunch of these in different kinds. These FJL 6920s. And you can see I have one installed. And this is how many HOTs I ended up going through. You can see these two are a different type. They're both 3688. They're both, all these are 3688. These were the three that I had on hand that I blew all those. I ordered 10 of these newer kind, and I got them from Arcade Parts and Repair. And Peter was kind enough to send me two alternate style 3688s because these should work. There's no reason, these are a direct replacement for what should be in here. But there's no reason why these shouldn't work. But I blew through these three and I blew through these two, the ones that he just sent me. And I had no idea why, because every single thing was checking good. So I ended up changing out C119 and C121 just for the hell of it, because these can cause HOT to blow. They check good in and out of circuit. And I put the two new ones in. This is a bit fatter one, the C121, C119, and it still blew the HOT, so that wasn't it. And then I went to turn it on and it wouldn't power on. It was completely dead. And it turns out that Q703 had broken a couple of legs because the heatsink gets moved back and forth. And that's why it's one of the most important things to check when you're checking this. If it's dead, you probably have a bad Q703 or an open one. So I had to replace Q703, which was this guy, this little guy right here. and then it powered back up again. Well, it didn't power up. I put another HOT in and gone. So I couldn't find a single bad component. We already know our power supply was good. We checked that with the light bulb. No bad components. I changed the caps out. It wasn't a bad cap. I could not for the life of me figure this out. So I installed one of these FJL6920s, the more robust replacement. Put it in there and fires right up. So I have no explanation. If there was something on the chassis that was shorted, that was taking this out because it was shorted or open or bad, it would also take out this one. But it's not. You can see it now works just fine. So I don't think there's a chassis problem or a component problem. I think that these may not work anymore. This is I had a U5000 that I already mentioned it before. I recently repaired it. It had the same problem, blowing HOT, blowing HOT, blowing. I couldn't find a single problem with it. Everything was in spec, nothing was out of range, and it was blowing HOTs. I put one of these in there, fired right up. So here's another scenario. Same exact problem, put a more robust FJ series in there, and it came right on, and it ran for a good hour with no problem. So that was the solution to this. Blowing HOTs, and now it's not. So after putting the more robust one in, I recommend using these because they have a higher tolerance. So if something is out of spec that I couldn't find, I checked every single resistor. I'm talking every single resistor, every single capacitor, every transistor, I checked everything. And I could not find the problem. So neck board's been the whole thing's been recapped, neck board rebuilt. So yep, now it's working fine. So I couldn't find any issue just putting the better HOT in there. It was not a flyback. I changed the flyback out with another one from another chassis that was working. It made no difference. It wasn't a flyback. It wasn't caps. It wasn't cold solder. It wasn't a broken joint. It wasn't... I thought maybe the horizontal width coil might have been bad, but that was okay. We know our power supply section was good. I checked all the ICs. I could not find anything wrong with this that would cause the HOT to blow. Nothing was shorted. And again, it shouldn't be, because if there was, it would take this one out too. So, yeah, I don't know. I can't explain it, but these work much better than the 3688s. At least in the last two chassis I've fixed, at least in my experience, that's what I see. And I can scroll through here with the test pattern generator, RGB, and it's just real nice. So, yep. Oh, and here's our conversions. So I can't explain it, but yeah, it turns out that nothing was actually wrong that I could find. It was just needed a more robust HOT, I guess. So I have no explanation. So anyway, it's working. So now we're 3 for 3, and stay tuned for number 4, and we'll see what we can find with that one. Actually, one last thing I forgot to mention is that you may notice that if you go back and look at the neck board when I was showing it off, there was a broken diode right there next to the... It's D507 right there. Oop. D507 right there on the right hand side, right there. Yep, right there. That was broken. I noticed that when I was putting this all back together. I noticed that it was broken. If you go back and look earlier, you'll see it's broken as well when I'm showing the neck board. So I did notice that and fix that. In case you saw it and you're like, hey, it's broken, you missed it. Well, I did miss it, but before I got this done, I did notice it was broken and I did replace it. So that's repaired. I also wanted to show the B plus here. Whoop, sorry. To check your B plus properly, there is a little post that's kind of bent on here. Right here by this capacitor, there's a little post. That's where you check your B plus on the K7500. So if you zoom back out and I take this and attach it here, there it is, you'll see 117. Now when we did our light bulb test, it would only go down to 134, if I recall. That's because there's not a complete load. You're putting a load on the power supply, but it's only powering that light bulb. This is trying to power and send voltage through the neck of the tube and energizing the picture tube. That's doing a lot more work than trying to light a light bulb. So when it does that, it dips down to about 117. This is what it should be set to, 117. Plus 5 is okay, but you want to have your B plus dialed in, and of course you adjust it with that pot right there. You can see the glues on there, but you can kind of take some pliers or some diagonal cutters like this, and use this. You can cut that glue and then it'll allow you to turn that pot. So be careful. If you have to replace it because you break it, that's, you know, what you have to do. But I was lucky in this case. So after getting all the caps replaced, all the troubleshooting done, HOT replaced, the new R104. All that was wrong with this was the R104 was bad, which probably took out the HOT, and I just had to put a better HOT in, and that's really all that was wrong with this chassis. I forgot to mention that before. But yeah, 117 is what you want to set it to. There's where you test it at. There's how you adjust it. And we've still got a great picture. So this has been running for about an hour now with no problem. So I simply can't explain why it doesn't like these, but it does like these. And again, if there was something wrong with this, it would be blowing this one too, and it's not. So obviously, I can't explain. So anyway, just wanted to point that out before we end this, and thanks again for watching, and stay tuned for part 5. Nope, I lied back again real quick. I mentioned before, when I was doing the light bulb test, that you want to have about 120 to 121 or 122. That's a mistake on my part, I'm sorry. It's not supposed to be 120, it's supposed to be 117. And you can see with it 117 I still have full image, full picture. My contrast is a bit too high. There we go. And I still have, even with 117, I have full width control. So yeah, 117 is where you want to have your B plus set on the K7400, 7500, U2000, U5000. 117 is what it needs to be set to. So that's it. Okay, now again, thanks, and we'll see you on the 4th video here.